The James Webb Space Telescope is unveiling objects in the deep, ancient universe that challenge our understanding. These discoveries are revealing vast, fully developed galaxies much earlier than previously anticipated. The telescope has provided evidence of 6 enormous galaxies that existed between 500–700 million years after the Big Bang, offering a glimpse into a time when the universe was still in its infancy. This finding is groundbreaking. Previously, scientists expected to see only small, young galaxies from that early period, but the James Webb Space Telescope has shown galaxies as large as those in our own time. These objects, which researchers are calling universe breakers, have forced scientists to reconsider how galaxies formed and evolved. The telescope's ability to capture infrared light, which is invisible to the naked eye, allows it to observe the faint light emitted by ancient stars and galaxies. This capability enables the telescope to peer back in time, up to around 13.5 billion years ago, near the beginning of the universe. This is remarkable because the universe is estimated to be around 13.7 billion years old. Many assumptions about galaxy formation have been appended. It was once believed that galaxies formed from small clouds of dust and stars that gradually grew larger over time. But the James Webb Telescope has provided images that suggest galaxies were much more developed than scientists expected, leading to new questions about how the first galaxies emerged. In July 2022, the telescope's high-resolution images were first made available, and the team was shocked to discover these massive galaxies. Initially, they thought they had misinterpreted the data when they saw these large points of light. The next step in their analysis involved spectroscopy, which separates light into different frequencies to study the composition and distance of these galaxies. The discovery was unexpected and came far sooner than researchers had predicted. The light from these distant galaxies suggests they are indeed galaxies, though some scientists speculate that they could potentially be massive black holes. Regardless, the data from the James Webb Space Telescope has already made a significant impact on our understanding of the universe's early stages. By analyzing the redshift of the galaxies, scientists can determine their distance from Earth. Redshift occurs because the universe is expanding, and light from distant objects is stretched to longer, redder wavelengths. Using redshift data, astronomers can estimate the time period of these galaxies, which have redshift values greater than 10. 4 galaxies with confirmed redshifts of 10.38 and 11.58 have been identified, and 2 of these are the most distant galaxies observed by the telescope so far. One galaxy has a redshift of 13.20, which corresponds to a time about 13.5 billion years ago, close to the early universe. This discovery was part of an ambitious program called the James Webb Space Telescope's Deep Extragalactic Survey, JADES, which has already provided incredible insight into the distant universe. The project is a collaboration of over 80 scientists from 10 countries, and it has already yielded fascinating results. Using the telescope's advanced infrared capabilities, the team focused on a small region of the sky, the Hubble Ultra Deep Field, and discovered nearly 100,000 distant galaxies. Through detailed spectroscopic analysis, they were able to gather crucial information about the gas and stars in these galaxies, providing insights into their intrinsic brightness and star populations. This work is just the beginning of what promises to be an extraordinary journey into the early universe. The James Webb Space Telescope, JWST, launched in 2021, is one of the most advanced and ambitious space observatories ever created. Its primary mission is to enhance the capabilities of its predecessor, the Hubble Space Telescope, by offering unprecedented insights into the universe through infrared observations. Unlike Hubble, which primarily operates in optical and ultraviolet wavelengths, Webb's infrared capabilities allow it to peer through dust clouds and observe celestial phenomena that are hidden from view by other telescopes. One of Webb's most impressive features is its enormous segmented primary mirror, which spans 6.5 meters in diameter, almost 3 times larger than Hubble's. This massive mirror is made up of 18 hexagonal segments that unfold like a giant flower after launch. This vast surface area enables Webb to collect more light, allowing it to observe faint objects at greater distances and providing deeper insights into the universe. Webb's instruments are designed for a variety of scientific purposes. The near-infrared camera, NIRCam, captures images in the near-infrared range, revealing distant galaxies, young stars and planetary systems. The Near-Infrared Spectrograph (NIR spec) analyzes the light from these objects to determine their chemical composition, temperature, and other properties. The Mid-Infrared Instrument (MIRI) covers an even broader range of wavelengths and plays a key role in studying the formation of stars and planetary systems. Lastly, the Fine Guidance Sensor/Near-Infrared Imager and Slitless Spectrograph (FGS/NIRIS) assists with precise telescope pointing and performs high-resolution imaging and spectroscopy. Among the many remarkable discoveries made by Webb, the identification of the earliest galaxies is particularly significant. Researchers have detected galaxies that formed when the universe was only about 300 million years old. These ancient galaxies challenge current theories about how quickly cosmic structures could have developed after the Big Bang. Observations of these early galaxies are crucial for understanding the timeline of cosmic evolution, especially in relation to the formation of the first stars and black holes. In addition to revealing ancient galaxies, Webb has made groundbreaking contributions to our understanding of stellar nurseries. Observations of regions like the Carina Nebula and the Orion Nebula have provided new insights into the processes of star formation. Webb's ability to penetrate dense molecular clouds has allowed scientists to study the earliest stages of star and planet formation, offering fresh perspectives on how these celestial bodies are born. Webb has also provided vital information about exoplanets. Its ability to analyze the atmospheres of distant exoplanets has led to the detection of molecules such as water vapor, carbon dioxide, and methane. These discoveries are crucial for assessing the habitability of exoplanets and understanding the potential for life beyond our solar system. As Webb continues to collect data, its observations of exoplanet atmospheres are expected to improve, offering a more detailed picture of these distant worlds. Another fascinating aspect of Webb's mission is its role in studying the formation and evolution of black holes. By observing the earliest black holes in the universe, scientists are gaining valuable insights into their growth and development, as well as their impact on surrounding galaxies. Webb's data is essential for understanding how supermassive black holes formed and evolved, and how they shaped the galaxies in which they reside. In addition to its observations of galaxies and black holes, Webb has provided new information about spectacular cosmic events such as supernovae and gamma-ray bursts. Its ability to observe these phenomena in the infrared allows scientists to study their aftermath and gain a better understanding of the life cycles of massive stars and the mechanisms driving the universe's most energetic explosions. The success of the Webb mission underscores the importance of international collaboration in space exploration. The telescope represents a joint effort involving NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. This collaboration has not only advanced our scientific knowledge but also demonstrated the power of global cooperation in achieving ambitious space missions. Looking ahead, the data collected by Webb is expected to continue revolutionizing our understanding of the universe. Future research will focus on further investigating the formation of the earliest galaxies, studying the detailed composition of exoplanet atmospheres, and exploring the physical mechanisms behind major cosmic events. The insights gained from Webb's observations will undoubtedly lead to new discoveries and expand our knowledge of the cosmos for years to come. In summary, the James Webb Space Telescope is transforming our understanding of the universe through its advanced infrared capabilities and comprehensive suite of instruments. From uncovering the secrets of the early universe to studying the formation of stars and exoplanets, Webb is setting new standards in astronomy and space exploration. Its discoveries are not only answering long-standing questions but also raising new ones, ensuring that the journey to unravel the mysteries of the universe remains an exciting and dynamic field of research. The development of worlds over time can now be fully examined, but understanding the early phases of a system's formation is crucial. Much like humans, the early stages of star formation have lasting impacts on future events. We are living in a remarkable era where many questions about the universe are being answered through groundbreaking discoveries. Some of the earliest stars began forming around 225 million years after the Big Bang, with star development in these young galaxies starting roughly 100 million years before the age at which they were discovered. NASA's Deep Space Observatory, which includes the James Webb Space Telescope, offers a fresh perspective on the cosmos. There is much more to uncover, as the telescope continues its pioneering journey in scientific exploration. Launched in December 2021, the James Webb Space Telescope is set to operate for at least 20 years, marking the beginning of its vast mission. Often regarded as the successor to the Hubble Space Telescope, Webb is setting new standards in scientific discovery and excitement by transforming raw data into images and insights that are being shared globally. While the James Webb Telescope was not the first to directly image an exoplanet, an important point that was overlooked, the telescope has made many other incredible discoveries. Webb resulted from years of effort by NASA scientists and engineers, and after its successful launch on Christmas Day 2021, its deployment proceeded smoothly. The telescope's first stunning images were unveiled in July 2022, providing an unprecedented view of the universe, including the most distant galaxies. Thanks to Webb's infrared capabilities, scientists can peer into the past, uncovering previously unseen celestial objects. In late June 2022, just after the telescope became operational, astronomers discovered thousands of new galaxies, some of which might have existed 150 million years before the oldest known galaxy. Webb's ability to gather light from distant objects such as exoplanets and infant stars has allowed scientists to analyze their structure and trajectories, revealing critical details about their atmospheres and the potential for life beyond Earth. By analyzing faint light from the universe's early days, the James Webb Space Telescope also uncovered what may be the oldest black hole ever discovered, a supermassive one that weighs 10 million times more than the Sun. This black hole was found at the heart of a young galaxy, just 570 million years after the Big Bang. Understanding how such massive black holes emerged so early in the universe's history is one of the telescope's key future goals. In addition, Webb has uncovered something even more intriguing: the discovery of galaxy protoclusters. These protoclusters are groups of galaxies in the process of forming, offering valuable insight into the early stages of galaxy formation and how these clusters evolve over time. Looking ahead, upcoming observatories like the Nancy Grace Roman Space Telescope, set to launch in 2027, will continue to expand our understanding of the universe. In the meantime, the discoveries made by the James Webb Space Telescope are providing an exceptional glimpse into the early universe, fundamentally reshaping our understanding of the cosmos and its history.